Hello, and welcome to the video portion for the Revolve Lab of ME123. The Revolve feature allows us to create rotationally symmetric parts, such as tops, rings, or bulbs. It comes with its own unique set of rules for sketch construction, so let's get started. I'm going to be working my example in a new part file, with my unit set to millimeters, and we're going to be drawing our sketch in on the top plane. To start, the most important part of a Revolve sketch is the axis of revolution. This is generally going to be a centerline, or any linear bit of construction geometry. In order to create our revolved feature, the sketch that we draw is going to be spun around this centerline, so it's usually going to be the first thing that we create in a revolve sketch. Oftentimes, the centerline is going to be either vertical or horizontal, but it can be drawn at any angle that's needed. Next up, we're going to have to draw the profile for our revolve feature. This is drawn within the same sketch as our centerline. The revolve profile is the shape that's going to be spun around our axis, so it has a few rules that it needs to follow. First, the revolve profile cannot cross the axis of revolution. It has to be drawn completely on one side of our center line. Next up, the revolve profile cannot touch the axis of revolution at any single point. Contact between the axis and the profile must be along continuous edges, like this. A shape along these lines would be acceptable for a revolve profile. But if this endpoint here were to be in contact with our axis of revolution, we would have an invalid revolve sketch. Breaking either of those rules is going to have SolidWorks give you an error message. One other thing to note is that you can draw a revolve profile that's disconnected from the axis of revolution. In this case, we have a circle that's floating a distance away from our axis. If we were to revolve that profile, it would leave us with a hoop shape. Now, before we get too much further into the revolve tool itself, there's a dimensioning trick that I would like to show you. When cylinders and circles are shown in engineering drawings, they're often dimensioned with diameters. However, in a revolve sketch, we only have access to half of the full cross-section of the shape, meaning that we could only really dimension a radial value. We could calculate the dimension by dividing the diameter by 2 and inputting the result, but that would be considered poor design practice. Fortunately, SolidWorks has a trick that we can use here called double dimensioning. When working within a revolve sketch, you can dimension from a known entity on the profile to the edge of our axis of revolution, and then move our cursor to the opposite side of the axis. This allows us to dimension a diameter value when we can only see a radial value, and is going to save you plenty of points on homework assignments throughout the quarter. Okay, now that we have our sketch fully drawn and defined, let's actually pop open the Revolve feature and see what it looks like. The Revolve feature can be found on the Features tab, directly to the right of the Extrude feature. Once we select that, we see that it opens up a new menu, and it shows us a preview. So, what can we do from here? Up at the top, we can choose a new axis of revolution. If there's only one construction line in your sketch, it automatically picks that one. Otherwise, you can choose any straight line that follows the rules mentioned earlier. Following that logic, we could choose this edge here, but we could not choose this edge here, as we have geometry on both sides of that line. Continuing down, we can modify the end conditions for direction 1. Similar to Extrude, there is a blind option, which allows us to type in a value. Revolve is one of the features where you can occasionally use numbers that don't show up on the drawing, specifically multiples of 90. If Revolve's angle isn't listed, you can usually assume that it's 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Let's see what other options there are. Up to vertex, up to surface, and offset from surface function exactly the same way that they do for Extrude. They aren't as common as the other options, but they can still show up on assignments, so I recommend experimenting with them yourself to get some practice. Midplane does show up relatively frequently, though it only matters if the revolve goes less than 360 degrees. Also similar to Extrude, there is an option to go in direction 2. In this case, it works exactly the same as direction 1, but in an opposite direction. Lastly, there's thin feature, which we're going to explore more in the next lab. Okay, so that about covers the basics. Let's look at how it can be used. In my experience, Revolve is usually the best choice of feature in two circumstances. Whenever there's a portion of your object that is rotationally symmetric, such as a spike or a lampshade, or whenever there's a profile that follows an arc path, such as the elbow joint in plumbing, or a bent cable of a clothes hanger. Let's start with the lampshade shape. While we're drawing our profile, it's important that we remember the rules that we had mentioned earlier, along with all of the rules that apply to sketches. You want to begin with your axis of revolution, and we need to make sure that we remain on one side of our axis. Also, as with all sketches that we draw in this class, we want to make sure that when we are finished, we have a single closed profile that is fully defined. Closing the profile can be something that is easily forgotten when dealing with revolve sketches, as oftentimes the edge that's collinear with your axis of revolution can be easy to miss. While we're here, I want the shade portion of this to be spherical. In order to get a sphere or a hemisphere shape, the center point of the arc needs to live on the axis of revolution. If it is anywhere else, the resulting shape is not going to be spherical. Okay, now that we have our geometry down, we can start adding dimensions. Using the trick mentioned earlier, we can dimension from a point on our object to the central axis to get a diameter, and going the opposite direction works as well. There we go. We have our fully defined sketch, so now we can go over to our Revolve feature, make sure that our values match up with what we expect, and hit our checkbox. Now that we have our base shape down, let's carve out a little indent on the shade itself. Since this cut is going to be using the same central axis, we could have done it as part of the initial Revolve. However, doing so would limit our editing options, making it so that it would be difficult to remove the carving for future iterations if we ever wanted to have a smooth version. Here, for our new sketch on the front plane, I'm going to be using the temporary axis of our initial shape to help us define our center line. We can toggle the temporary axis visibility here by hitting the drop down and selecting temporary axes. Here, I'll draw a center line, and then we can define it as being collinear with the temporary axis. You can get a temporary axis from anything that is rotationally symmetric. It doesn't have to be a revolve. Extruded cylinders also have temporary axes. In the end, this is going to result in doing the same thing as if we had drawn our center line coincident with the origin and set to vertical, but on some occasions this methodology can be more reliable. Now we'll draw in our geometry and add in the relevant dimensions. To help fully define our sketch, I'm going to set so the center point of our circle is coincident with this edge of our revolve. Add in the last few dimensions, swap over to the Features tab and select Revolve to Cut, and hit our checkbox to finalize the shape. Okay, so what about the arc option? Let's say that this lampshade has a hook on top that's made of a cylindrical wire. For these kinds of shapes, we want to leave the profile disconnected from the axis of revolution. In this case, our profile is going to be drawn centered on the top surface of our lampshade. In this case, we're going to have a circle here to get our cylindrical wire, and then we can draw our axis of revolution floating in space. We'll dimension it so that the axis is a distance away from the center point of our profile that matches up with the radius that we're given in our drawing, or that we've measured from our shape, in this case 50 units. And then we can go over to our Revolve feature and set our angle down to 30 degrees. Of course, if your Revolve is initially going in the incorrect direction, you can flip the directionality by hitting the reverse direction button next to the end condition. That looks about right, so we'll hit our checkbox. And now we're stuck. We've already used the diameter of our cable down here at the bottom, and we're not allowed to reuse the dimension, so we're going to have to get clever to figure out how it is that we can produce the hook portion. We know that the two revolves are going to have their profiles match up, so we can draw our second revolve on this new surface here. And in order to get the profile of our new shape, we can use Convert Entities on this surface to get a duplicate of the circle. Now we just have to draw in our new center line, which is also going to be vertical, and we're going to set its distance from the axis to the center point of our profile to 50 units. Now that our sketch is fully defined, we can swap back over to Features, select Revolve Boss Base, and set our distance to 260 degrees. And we're done. So, that about covers everything that I wanted to talk about for this lab. The Revolve feature doesn't have as many options and new concepts as Extrude did, but it is one of the fastest ways to get certain shapes, making it one of the fundamental features in SolidWorks. Have a good day, and we'll see you again next time.